This talk will first look at, see what GENI is, what GENI is about. We'll look at an example of how GENI might be used. Talk about GENI's growing suite of infrastructure, how GENI is growing in scale, and say a little bit about experiments that are being run on GENI. Look at the future for GENI and collaborations with various entities such as US Ignite, DREN, and then a quick introduction to what it looks like, what GENI looks like to an experimenter. What is it? How do you use GENI for experimentation? So we all use global networks such as the internet, and these networks have posed, they've provided a lot of opportunities, but they've also posed a lot of challenges. First are the science issues. We deploy these networks, but we really don't understand how the science behind these networks. They're largely engineering efforts. We deploy them, see how they work, and if they don't work quite like we want them to, we make some tweaks to the network, but we can't really predict the behavior of especially large-scale networks. Then there are innovation issues. The internet is a production network. It's used for mission-critical things such as banking, Facebook updates, and the like. And really, you cannot go to AT&T and say, hey, I have this idea for a really cool routing network in the backbone. Will you please deploy this in your routers? They're not going to let you do that. And so all the innovation that happens today happens at the edges of the network. You have novel client applications, you have novel services, web services, but there's almost no innovation that happens in the core of the network. The protocols we use today are the same that we used 20 years ago or more. And then there are societal issues. The internet is a mission-critical network, it's a production network, and yet there are security issues, privacy issues, and reliability issues that we grapple with every day. And we really don't have a good scientific way of dealing with these issues. To address these, the National Science Foundation is funding the creation of GENI, which is a laboratory for exploring future internets at scale. So it's a test bed. It's a laboratory where you can try out new ideas you might have for networking protocols, networking applications, and the important thing is you can try this at scale. Unlike research that's typically done in a lab, maybe proved out with a dozen or at most a couple dozen computers. Now you can actually do it at scale. So GENI opens up opportunities for leading edge research because you can now do things at scale, and you can deploy your protocols at any level of the protocol stack. And this, we hope, will lead to rapid innovation. We'll have new applications that are enabled, new technologies that are enabled. There are two key concepts that underlie GENI. One is the concept of a slice. So GENI is a shared testbed. You have multiple experimenters, multiple researchers using this shared testbed. So the way we deal with this is each researcher gets his or her slice of GENI. So the resources in GENI are divvied up amongst these experimenters, and these are what we call slices. And an experiment lives within a slice. So every experimenter works within a slice. The resources used by the experimenter live within that slice, and slices are isolated from one another. And the other concept key concept in GENI is deep programmability. What this means is you can program at any level of the network. You can program the end hosts, you can program any intermediate networks and intermediate routers and switches. You can deploy your software right in the backbone. So you can program any part of the network. And what this means is then you can try out novel, novel protocols, whether they're backbone protocols, they could be protocols at the boundaries of networks. You can deploy your protocols anywhere you wish. So this graphic explains the concepts. So here we have two researchers both running experiments on GENI. Each experimenter is operating within a slice of GENI. And so in this case, for example, we have an host, and each experimenter has, in this case, a virtual machine running on the host. So that's how this host is sliced up, is divvied up amongst these experimenters. Likewise, in the intermediate, in the routers in the network, again, they are divided, they are sliced, and and each of these experimenters gets a portion of that resource. And slices are isolated, so they don't interfere with one another. And slices, in this case, span end hosts, intermediate hosts, and these researchers can install their software anywhere in this system, in this test bed. And each of these researchers could be experimenting or trying out an entirely new future internet protocol. And in fact, we do have in GENI slices running where future internet architecture researchers are running their experiments, trying out their protocols. The NSF has funded 4 large projects to look at future internet architectures, and what they will be doing is essentially running in 4 different slices. So you can have 4 different visions for a future internet running on GENI at the same time. So GENI is now going live across the US. We have GENI-enabled testbeds, campuses, and backbones. What this means is there are a wide variety of resources available in GENI, distributed all over the country. And I'll go and further describe some of these resources as we go along in this talk. But as you can see in this figure, there are 2 backbone networks, Internet 2 and National Lambda Rail, that connect all these resources together. And so you can set up a slice that spans the country, and you can put your own software even in the backbone nodes in National Lambda Rail or Internet 2. Questions so far? All right. So how does one use GENI? So this is kind of a cheesy cartoon to explain how GENI might be used. So here we have a researcher who says, hey, I have a great idea. The original internet was designed to connect computers. It was essentially supercomputer centers connected to one another. And he thinks that what we need today is a fundamentally new internet architecture. Something that's based on connecting people, not computers. And so he comes up with an idea for a protocol stack that would enable this. And there are the usual chorus of critics who say, oh, this will never work, this will never scale, it won't be secure, and so on. So what he does is he implements his new protocol stack, tries it out in his lab. Things go well, so he decides to now actually try it out on GENI, someplace where he can get a large number of resources, and someplace where he can actually get real users to try his protocol. So he takes his software, he goes to GENI, gets resources in GENI, perhaps a couple WiMAX base stations in different parts of the country, connects them up using the backbone networks. There are some intermediate switches he gets where he can put his software, and perhaps some cloud resources to do some processing. And so he creates a slice, gets resources, adds them to his slice, and now he has his network set up. He can install software in all these resources that he acquired for his experiment. So he starts off with a modest slice, tries out his experiment, learns a lot, and he gets people to try how to service. They connect to a service using their cell phones through the WiMAX base stations or through other means. And word gets around about this cool new service this experimenter has. More people start using the service. He grows his experiment by adding new resources to his slice. So he grows his slice, And he does well. He gets publishes a lot of papers. He has a lot of happy users. People connect to his users connect to his slice, but from phones or using apps on their applications on their computer. Some might be coming through the internet. Some of his users might be coming through using entirely new protocols that get installed on their phones or computers. So there are different ways of getting to his resource, to his service. And because his experiment is a success, he decides to take it off GENI and spin it into a company, gets rich, and lives happily ever after. So we hope every experiment has this happy ending. We know it won't, but that's anyway. This is intended to convey to you the kind of how experimentation GENI works. You first try it out in your lab, and then you take it to GENI, get a few resources, check it out, and if it works, you can of course grow the experiment. And then an important takeaway from that experiment is the fact that you can have real users use your experimental services. You can have them, connect to your service, try it out, tell their friends about it, and so you can have real users collect real data on how users might use the service, and you can do this at scale. So if you have an idea for a novel protocol, the place to go is the NSF SIZE Directorate, which actually funds the research in network science and novel protocols. Once you have developed your ideas and you would like to try them out, please come to GENI and talk to us. We'll be happy to help you set up your experiment in GENI and help you test out, prove out your protocols, your ideas. Okay. So GENI is meant to enable at-scale experiments. So by at-scale, I mean at sufficient scale to convince yourselves and your reviewers that this would work in the public internet. You can run both repeatable and in the wild experiments. So what I mean by this is you can, if you want, constrain the resources you get in GENI, so you can repeat this experiment multiple times, and other people can repeat your experiment and get the same results. Or you can do in the wild experiments, which means you deploy an experiment, deploy a service, see how it works out. So you may not really think hard about controlled or uncontrolled variables and about repeatability. You just want to see how this service gets used by people. You can get opt-in users, real users, to use your services. GENI has instrumentation measurement tools, which, as you might expect, is key for scientific research. And then the scale. You can grow your experiments to large scale, which is really important for any technology that will eventually get deployed on a public internet. So how are we building GENI? So the GENI project is organized into spirals. It's the classic spiral development method. So at the start of each spiral, we set out goals for the spiral. What are the key risks to be addressed? What are the key objectives for the spiral? And lay out the plans for the spiral. So we are currently in Spiral 4. Spiral 4 started in October of last year. And the goal in Spiral 4 is to ramp up experiments. So it was really gratifying to see so many of you here looking at using GENI for your research, in your classroom. And that's exactly what our goal is in Spiral 4, to get people such as you using GENI. So as part of getting people to use GENI, we have added 24/7 support. The Indiana University Global Meta Operations Center is providing 24/7 support. We are adding what are called GENI racks. These are, I'll say a little more about these, but these are essentially think of these as mini clouds deployed around the network, around the country. More OpenFlow, which is a software-defined networking technology. I'll say a few words about that later, and WiMAX. And we're also deploying 2 integrated instrumentation measurement systems in this spiral. The goal is eventually to have a large-scale distributed computing testbed connected by high-speed backbones. And that includes a variety of resources and networks, including wireless networks and sensor networks. So, as I said, we are in Spiral 4. And so you might be wondering, how can we build a testbed that is at scale, that is large, and yet affordable? And the way that we do that in GENI is by what we call federation, the notion of federation. So over the years, the NSF and other organizations have been funding the creation of different kinds of research testbeds. You might have heard of Planet Lab, you might have heard of MU Lab, Orbit. All of these are networking research testbeds that have been funded and built over the years. What GENI does is takes testbeds such as these, takes existing network deployments, campus networks, regional networks, backbone networks such as Internet 2 and National Lambda Rail, and GENI enables them. What that means is, technically what that means is they all now have a common API called the GENI Aggregate Manager API, which essentially gives you a common way of getting resources from these testbeds, adding them to your slice, and when you're done, releasing the resources, and so on. So it's a common API that all these testbeds and networks support. So that's the technical part of the federation. And then there's the operational part of the federation, which means that all these different owners of these testbeds come together and say, yes, we will provide our resources to GENI experimenters, and yes, we will recognize if somebody comes with the GENI credentials, with a GENI account, we will give them resources. And yes, we will work with GENI operations to handle things such when bad things happen, or to make to make sure that the whole testbed works smoothly. So federation is the process by which the GENI testbed happens. There's the common API, and then common or shared operations, and shared and recognition of GENI accounts by all these testbeds. So the kinds of I mentioned some of the things that some of the organizations coming together in these testbeds. I mentioned campus networks, I mentioned existing research testbeds, regionals, and backbone networks. This again reinforces the federation aspect. And for this federation, the emphasis has been campuses, federating campus networks into GENI, and also deploying resources on campuses, resources such as GENI racks. And the reason for focusing on campuses, one of the main reasons is that's where the future researchers are. That's where the future users of the next generation, of the next internet are. And students are early adopters. So if you have an experiment, the most likely early adopters of your experimental services are going to be students. And so we want to be where the students are, where these early adopters are. And so GENI enabling campuses is a key part of our strategy. In fact, on Thursday this week, there is a meeting of campus CIOs that happens right after the GEC, and all that is related to deploying GENI at more campuses. And when I say GENI enable a campus, what that means is we already have an existing campus network. We deploy technology called OpenFlow, which allows the existing campus network to be shared between production usage and experimental usage. So you can say a certain part of the network is going to carry experimental traffic. It could be non-IP, and this lives in this happens on the same network, the same fiber, the same switches that are used to carry production traffic. And a number of campuses are already GENI enabled. Georgia Tech is an example of a campus that is one of the early campuses that were GENI-enabled. And key to GENI-enabling campuses is, one, you need to have a researcher who's very interested in getting GENI to his or her campus, and the campus, supportive campus CIO. This cannot happen without IT support, without the support of the IT organization, because it's their network that we are, I guess, borrowing for research. And Georgia Tech is an example of where we had a couple of researchers, Nick Feimster and Ellen Zegura, and their IT staff who were forward-looking, and so this is a great success. In terms of deployments, the left side of the slide, top left, marked OpenFlow. Those are campuses where OpenFlow technology has been deployed. This is the technology that allows the campus network to be shared for production experimental use. On the top right, you see WiMAX. So these are campuses where WiMAX has been deployed. And then the map also shows locations of OpenFlow switches in the backbone. So these are places in the backbone where you can, again, control the behavior of the switch. And ShadowNet is an instrumentation system that's also deployed in the backbone. And the picture at the bottom shows some of the commercial equipment that has been GENI-enabled. So for this commercial equipment, essentially, in most cases, it's just a firmware upgrade. So it's not that campuses need to buy new equipment. It's a firmware upgrade to their existing switches. So that's, again, something that's made it possible to actually GENI-enable campuses. Any questions so far? All right. I mentioned National Lambda Rail and Internet 2, providing backbone network services for GENI. And at their various, at some of their points of presence, we actually have GENI equipment installed, programmable switches, and so on. And as of it's almost a year now, we have had layer 2 splices, so essentially Ethernet virtual VLANs that span campuses. These VLANs go over Internet 2 and National Lambda Rail. Each VLAN consists of about 25 or so OpenFlow switches and computers, 40-some computers. And this OpenFlow technology is deployed that allows you to actually, OpenFlow controllers are deployed that allow you to actually manage your slices within these VLANs. So the takeaway here really is that we do have since August of last year, we've been setting up a layer 2, essentially VLANs across the country, and going over the backbone networks, going over programmable switches, and they are available and ready to use by experimenters such as you. And in fact, they have been used by experimenters. Later on in my presentation, I'll give you examples of experiments that use this mesoscale deployment of GENI, the OpenFlow backbone networks, and so on. Here's a graphic that again shows the OpenFlow backbone. The nodes in blue are from National Lambda Rail, there are switches deployed in the National Lambda Rail backbone, and the red switches are those deployed in the Internet 2 backbone. And these backbones connect to regionals and eventually to your campus. A large number of organizations are involved in building GENI. The large number of universities, and at the bottom are the commercial entities involved with GENI, either by GENI enabling their switches, their equipment, or providing networking or such resources for GENI. So I mentioned experiments. I mentioned experiments that used the GENI mesoscale deployment. So in about a November 2010, so a year and a half ago at the GEC, there were a number of demonstrations. These were demonstrations by students, PhD or master's students, who used GENI to prove out some of their ideas. And here are some examples of some of the demos that, excuse me, that we saw. There were 9 demos, and as I said, they were all students. They all used the GENI mesoscale deployment. So, for example, there was a student from the University of Illinois, and his experiment was about, it was, let's see, this one. Oh yeah, so he had this notion of resilient routing in the internet using the source-based routing, and it was a non-IP based protocol, and if there was a fail link, there were ways of routing around it. You might say, yes, this happens in the internet today. This was in this case, the finding of the alternate path happened in real time. You didn't have to, there was no, today if there's a failure of a link, you have to detect the failure of the link and then find a new route. In this case, the adaptation happened really quickly, and the failure of the link did not affect critical traffic flows in the network. Again, this was possible because, one, it was a non-IP based protocol. He could do things that we cannot do in IP, and he actually showed this working in on a nationwide deployment. There was another demonstration of a content distribution network. This is by Columbia University, and they were actually caching content in the network and moving the content around the locations of the caches as the demand for the information changed. Again, they were taking advantage of the fact they had now access to the core of the network. They could put their own software. They could cache their own data in the network and move things around. They had control over the network. There was a experiment that led out of the University of Massachusetts at Amherst, and they demonstrated a nowcasting application. What this means, what this was, is an extremely short-term forecast, a forecast of, is it going to rain in this certain location an hour from now. They took weather radar imagery from the University of Amherst has a atmospheric research lab where they have real weather radars. Those weather radars are actually federated with GENI. What this means is that you as an experimenter can actually include a weather radar in your slice and collect and control this radar. You can have it collect imagery from pointed in different directions and collect images. So they showed how they could get the data from these weather radars, essentially a sensor in their case. They could send it over high-speed pipes to a cloud computing facility, crunch on this data, and get the forecast out to where it was needed. And so they showed how this could be done on demand, based on location or based on time. You could say, I would like to know if it's going to rain an hour from now and in Boston, and they could do that for you. Finally, there was an experiment out of Stanford. It's load balancing in the network. So what they had was a number of servers deployed in different parts of the country, and you had clients coming from different places. And today, if you were to do something like this, what you would do, the load balancing would essentially happen at the entry to the network. When a client hits the network, you would decide, well, I'm going to send this client to this particular server. That's what companies such as Akamai and others do today. What the Stanford work did was actually do load balancing in the network, which means you could dynamically decide in the network where you're going to send the traffic from this client. You would decide this based, so since you're doing it in this, excuse me, in the network, you could base your decisions on how the network was doing when the traffic hit the network. You can make your decisions based on knowledge that in the network that you would not have at the edges, and so they could do a much more efficient job, much better job of balancing network load in the network. So I think those are the examples. So hopefully these experiments gave you a flavor for the kinds of things you can do with GENI and the advantages of using GENI. The fact that you can program the core of the network, the fact that you can actually try this out with a number of resources at scale. All these experiments used resources from across the country from multiple campuses. So that's essentially what I would like you to take away from these experiments. That the GENI enables these kinds of experiments, and more, of course. So, any questions before I move on? Okay. So what's next for GENI? Well, I mentioned the mesoscale deployment. We saw the list of campuses with WiMAX deployments, the list of campuses with OpenFlow deployments. So now the goal is to GENI enable 100 to 200 campuses, and that would be kind of the at-scale deployment of GENI. And this deployment would include academic institutions, national labs, and we'll continue to do this using the spiral development process that we've been using. So each spiral will identify more campuses, more labs, and deploy GENI into those campuses and labs. And of course, this is we're not going to 200 campuses overnight or even in a year. We're going to do this slowly over time. So as we learn, get experience with these deployments, we'll have we can take this experience on and make it easier for future deployments. In fact, the thought is that we would have some kind of a buddy system, so where a new campus that's getting that's being GENI enabled would be paired up with a campus that already is GENI enabled, and they would act, and the campus that is GENI enabled would act as a buddy or a mentor to the campus that is going to be GENI enabled. And eventually, we need to transition to community governance. The GENI project office currently manages the deployment of GENI and coordinates the operation. Eventually, this would have to be community-based. The community will have to take on the governance of GENI. So that's something else that's being worked out. And the eventual, excuse me, goal, or what we'd like to see, where GENI is headed, is I'm going to start at the left, where we have people living in homes. We have people accessing GENI experiments or resources from wherever they might be, homes, coffee shops. They would come to GENI, to connect to one of the GENI backbones, where they might connect to a slice running a GENI service. And the slice would, of course, have to span regional networks that connect the homes and coffee shops to the backbone networks, and eventually to campuses where the experimenters might live. So if you look at the architecture, the current internet would still be used as the control plane of GENI. What this means is we'll continue to use the current internet, the IP-based internet, to set up slices, to set up experiments. So an experimenter would use, there are protocols called the GENI control framework that talks over the internet and sets up the data plane for an experiment. The data plane could be VLANs, Ethernet VLANs, running whatever protocol the experimenter wishes. But once the data plane is stitched, once it's been set up, everything has been connected, then we can have it would connect experimenters and end users, and their traffic would go over the data plane. So just to repeat that, the internet, it will continue to be used to set up the experiment, the data plane, and then the data plane would carry the experimental data. And that's that's how it is today, and that's how we envision it would continue to be. And one of the things exciting thing that's happening is the deployment of a OpenFlow backbone or OpenFlow network in Internet 2. Internet 2 is independently deploying a large number of OpenFlow switches in their network. And so this is good news for GENI, because this means that, and since Internet 2 is making resources available to GENI experimenters will now have access to a nationwide OpenFlow testbed, or a network, rather. Earlier I'd shown a picture with maybe a dozen or so OpenFlow switches in the Internet 2 backbone. There'll be a lot more now with this deployment. So that's really exciting news for us in GENI land. Excuse me. And then I mentioned the growing of GENI to 100 to 200 campuses. There was a solicitation last year soliciting proposals from campuses who interested in, soliciting teams to build what we call a GENI rack. Essentially, it's a rack with compute servers and OpenFlow switches that we could just deploy on campuses. Two teams were selected to build these racks, and they'll be deployed to about 30 campuses in the next 2.5 years. And the plan is to build out or expand GENI's footprint into 100 to 200 campuses in the future. And there will likely be solicitations coming out for proposals from campuses interested in getting a GENI rack or OpenFlow enabling their campus. As part of the last solicitation, one of the things that's going on, and one of the activities in Spiral 4 is the growing of GENI into the regional networks. So we had GENI, we had started GENI enabling the backbone networks, Internet 2 and National Lambda Rail. We had started GENI enabling the campus networks by OpenFlow enabling them. But then there are the networks between the campus networks and the backbone networks that were really not GENI enabled. So if you wanted to connect a campus to another campus, you would have to actually call up your regional, talk to them, and see if they could set up a VLAN for you so you could go from your campus to a backbone network. Obviously, that's not optimal. Most of us don't even know who our regional might be or who we might want to call. So part of our push in Solicitation 3 and starting in Spiral 4 that started in October is to actually get more regional networks on board. OpenFlow deployments in regional networks, GENI racks and regional networks. So until Spiral 4, we had 2 regionals on board. We had the Texas Learn network and the Mid-Atlantic Crossroads network as part of GENI. We kind of learned what it means to GENI enable a regional, and now we have all these other networks, other regional networks that are being funded to be GENI enabled, deploy OpenFlow switches, and participate in the setting up of VLANs that can go right from campus all the way to the backbone. So that's really important for experimenters, because it's now actually possible to set up a VLAN that goes from your office on campus to a backbone and pops up in somebody else's office on the campus at the other end of the country, without having to make phone calls, find out who your regionals are and who to call, and persuade them to give you a VLAN. As part of as part of the campus build-out, there are more WiMAX base stations being deployed with Android handsets. So you can now this is an easy way to get real users to use your experimental services. I mentioned the regional networks, more OpenFlow switches, and then GENI racks to 50 to 80 locations. And as far as campus expansions go, these are being coordinated by Larry Landweber at the University of Wisconsin. And he essentially keeps a list of which campuses get GENI racks or get OpenFlow deployments. And if you'd like to move up in his list, he's the one to talk to. We actually have a waiting list. There are more campuses waiting to get GENI enabled than we have racks or resources. We're also ramping up workshops for experimenters, to train people up in using GENI. Indiana University will be running 3 workshops a year. This is primarily for campus IT. It's focused on OpenFlow and what it means to deploy OpenFlow on a campus network and how one might do that. And at the GECs, there have been, even at the GECs, there have been training workshops for campus IT. Let's see. I mentioned our US Ignite came up earlier. There were a couple people here who said they were part of the US Ignite. So the US Ignite is an initiative out of the White House to spur the development of novel applications that take advantage of high-speed networks. So the US Ignite effort it's a private-public partnership to take advantage of high-bandwidth, high-speed networks in cities to deploy applications that might be of benefit to the citizens. The areas they're focused on are manufacturing, health, education, energy, transportation, public safety. And so if you have a application that you think falls in one of these categories that could take advantage of the high speed, the gigabit networks deployed in some cities around the US, US Ignite is who you want to talk to. And the NSF is keen on federating GENI and the US Ignite testbed. What that means is, as a GENI experimenter, you can deploy applications or experimental services that is made available to cities or citizens of cities that are part of US Ignite. So you can create slices that might take advantage of resources in the US Ignite cities, and people living in the cities can use your services. And this thing is just a few months ago, or maybe a month ago, there was a kickoff at the White House where this whole US Ignite effort is kicked off, and there are a few cities. Chattanooga, I think, is one of the here this list of cities where the strong interest: Chattanooga, Cleveland, Lafayette, and so on. And I think I already mentioned all this. So for you as a researcher, what this means, as I said, is you have access to these resources. What will likely happen is in these cities, we would deploy a GENI rack and a OpenFlow enabled switch. You can get to the network in the city using regular internet, regular ISP, the GENI control framework. You would use the GENI control framework to set up layer 2 connections that go between the GENI rack in the city to other GENI resources elsewhere in the GENI testbed. And you can deploy your services in this rack, and citizens could get to your services either through the internet or through the novel protocols using applications you might provide for them to install on their phone or computers. Again, one of the things about GENI, because of the slicing, as I said, you can have multiple experimental services running in different slices at the same time. So citizens in these US Ignite cities may be able to subscribe to different slices, might connect to different slices to get different kinds of services. It's kind of like, let's say this future internet architecture number 1 running on slice 1, architecture 2 running on slice 2. They could choose which future internet protocol they want to use by switching applications or changing some settings on their computers and getting access to different kinds of experimental future internets. And this is all very feasible with the GENI architecture, and this is where we hope to be headed with the partnership with US Ignite. So looking forward, we GENI solicitation 1. This is the first round of proposals that are awards that were made to actually build GENI. This happened in 2008. So those efforts are ramping down. GENI is essentially much of the work in building GENI is done. The technical design is done. And so those efforts are ramping up, and now the efforts in solicitation 3 that I mentioned are all focused on growing GENI, both in scale and the number of users. And in Spiral 4, we're looking to grow to 20 plus campuses. Okay, so the next part is about what does GENI look like to an experimenter? Some of the nitty-gritty experimentation with GENI. So I'm going to, I guess the next few slides are structured to mirror the workload of or the workflow of a typical experiment that you might do on GENI or elsewhere. So as part of any experiment you do, first you plan the experiment, you figure out what resources you need, what tools you need, then you actually deploy your experiment, then you execute it. So I'm going to talk about each of these steps and how they relate to experimentation in GENI. So the first thing, of course, you have an idea, you want to try it out, you need to see what resources are available. So you want to see if GENI is the right test bed for you. So if you go to the GENI wiki, so if you go to www.geni.net and follow the link there to the GENI wiki page, there's a link to GENI wiki. You'll find a link to a page called Understanding GENI, which lists all the available resources in GENI. It lists backbone nodes, other different kinds of aggregates. It has a brief description of each aggregate. Aggregate, once again, in GENI world, essentially is a collection of resources owned by an entity. So, for example, if you're familiar with Planet Lab is an aggregate. It's federated with GENI. It's managed by the Planet Lab consortium, and they make resources available to GENI experimenters. A campus might be an aggregate because it makes resources such as a rack or its campus network are available to GENI experimenters. So you can, and also associated, also along with each of these aggregates, it also lists the tools that you might be able to use you would be able to use to program that aggregate. So let's say you decided GENI is right for you. It's got resources that are exactly what you need, and now you want to try it out. So you need a GENI account. You can get one today. Ask anybody from the GENI project office. There's a GENI help. There's a GPO help desk outside, or just catch one of us from the GENI project office. We can help you. You can always email help@geni.net at any time, and we can help you get an account. There's the web page there listed here. The URL. You can go there and get an account. And if you're a student, your account will have to be approved by a professor. So you have an account now, and you know what resources you would like. You don't have the resources yet, but you know what resources you'd like. Well, you build the software that you would install in these resources. And the software tools and languages you use, of course, depends on the resource. If you have a resource, if you got a virtual machine that is going to be running Windows, you would have different sets of tools and languages than, say, something that's going to be using Linux. So as I said, each aggregate provider provides some information on suggestions for tools that you can use to program the resources. At this GEC, we have tutorials on programming certain kinds of aggregates. At 1:30 this afternoon, there's a tutorial on how to program the GENI racks. This is one of the kinds of racks that will be deployed. And at 1:30 tomorrow, there's a tutorial on programming the GENI racks. And at 8 a.m. on Wednesday, there's a tutorial on programming the WiMAX base stations, base stations. So if you think any of these kinds of resources might be of interest to you, you might want to go to these tutorials. So now you know how to, you've decided on what resources you're going to use. You've developed your software for these resources. Now you want to deploy your resources in GENI. So I mentioned earlier that a slice, the notion of a slice, which is an abstraction for a collection of resources capable of running an experiment. As I mentioned earlier, an experiment lives in a slice. So it uses resources that are in the slice. I mentioned the slices isolate experiments. And you as an experimenter are entirely responsible for your slice. So if something bad happens in your slice, you start sending traffic that you shouldn't be sending out to the open internet. There's content in your slice that shouldn't be there. You're the one who will be held responsible. So you are the slice owner. You as the owner of a slice are responsible for what happens there. So how do you create a slice? You go to what's called a slice authority. So you go to a slice authority and say, I would like a slice. And there are currently 3 slice authorities in GENI, and you can go to any one of them. And what you get back are slice credentials. So a slice is created, and you have given credentials to the slice. What that means is now you, with those credentials, can add resources to that slice. You can delete the slice and do things to the slice. Then we have the notion of slivers. I mentioned how GENI is a shared test bed, and you get portions of resources. Well, a piece of a resource that is given to you as an experimenter is called a sliver. So what that means in a compute node, that could mean a virtual machine. Your sliver is a virtual machine. On a backbone network, it could be a VLAN. So there are multiple VLANs sharing the same network. Your VLAN is the sliver you get. On a FPGA, in that FPGA, it could be a certain number of gates you get. So those are all slivers. And so the way you describe resources in GENI is using a language called RSpecs. So it's kind of a language for negotiating resources. It's a low-level XML-based language, kind of like machine language would be the analog. And so when you want a request, you would craft an RSpec that says, I want a resource that looks like this. And then and this is an example of a RSpec for requesting a single node. Obviously, it's not something you want to be writing often or ever. And fortunately, there are tools that do this for you. There are tools that create these RSpecs for you. So how do you use RSpecs? There are 3 kinds of RSpecs. There's something called an advertisement RSpec. So when a resource owner, an aggregate, advertises the resources it has using what's called advertisement RSpecs. So in this case, this experimenter here goes to an aggregate and says, list the resources you have, and she gets back an advertisement RSpec. It's the aggregate saying, these are the resources I have. Now she says, okay, I would like a subset of these resources. So she crafts what's called a request RSpec. This is telling the aggregate what she wants. In this case, maybe I want 4 virtual machines connected by these kinds in the certain topology, and I would like my virtual machines to be running the certain OS. And in addition to that, I'd also like a bare machine, a complete PC of the certain class. So she crafts an RSpec, sends it, her request RSpec sends it to the aggregate, and the aggregate sends back a manifest RSpec saying, this is what you got. These are the compute nodes you got. These are the IP addresses. These are the MAC addresses. It's a complete description of the resources that she actually got. If she went back to the aggregate manager and did the list resources with her slice name, she would get back the resources, the same manifest she got earlier, essentially the resources that were assigned to her slice. So three kinds of aspects. These are essentially XML documents. Advertisement aspect, request aspect, and manifest aspect. You'll be mostly dealing with request and manifest aspects in your tutorials. So the manifest aspect, as I said, has information about the resources that actually got allocated to the experimenter, things such as host names, IP addresses, and so on. And this is sufficient information for the experimenter to actually use the resource to SSH into a certain IP address, for example, and install software. So the experimenter now needs to install her software on these resources. Well, she can SSH into each of these machines and install software. Again, obviously, this does not scale, and fortunately, there are tools to help do that. There are tools such as Gush, Raven, and Flak that can automate the installation of software on these resources. There's a tool called Raven that goes even further. It not only installs software once, but if you update your software in a repository, it detects that and pushes these updates to all your resources. And there's a tutorial. I mentioned Flak. There's a tutorial at 1:30 tomorrow. There's the GENI tutorial that'll have a little Flak component to it. And then this Floodlight is an open flow controller tutorial that happens at 1:30 today, and that'll talk about programming and pushing software to open flow controllers. So now our experimenter has installed software on all the resources. She's acquired resources by negotiating with these various aggregates. She's installed the software. She's ready to run her experiment. There are tools such as Gush that are available to control experiments, to start an experiment, resume, stop, so on. There's also a GENI aggregate manager API that one can you can make XML RPC calls to inquire about the status of a sliver, to stop and delete a sliver. Yep.
Do all GENI racks belong to the same aggregate, or each one of them has a different aggregate manager?
Each rack has its own aggregate manager because each rack is managed by a different organization or different campus, and they might have different policies on access. So each rack has its own aggregate manager. So if you want resources from 3 different racks, you would go to each of those aggregate managers and get the resources you want, and then you would go to the aggregate manager for the backbone network, for example, to get a VLAN to stitch them together. Okay. I mentioned controlling an experiment. Instrumentation is obviously extremely important for any kind of scientific experimentation. Currently, there's a tool. There are multiple instrumentation and measurement tools in GENI. As I said in solicitation 3, we are funding the 2 large projects to build unified instrumentation measurement tools. There are tutorials. The 2 systems are called GENI and Gemini, and there are tutorials at 1:30 today and 1:30 tomorrow on these new instrumentation measurement systems. And then finally, when you're done, you tear down your experiment. There's an API called delete sliver to delete your resources. There's a tool called Flak I mentioned. I think I said there's a tutorial at 1:30 tomorrow. It's a graphical tool for dragging and for creating adding resources to your slice. So you can use Flak to discover resources, drag and drop them onto your slice, and set up your experiment. There's a tool called Omni, which is command line driven. Obviously, it scales better than Flak. So if you're using large experiments, you might want to use Omni. Then there are other tools such as Gush and Nebula, also designed for experiment control. And there's a tool called OMF it's a suite of tools for, for deploying experiments, controlling experiments. There's a tutorial right after the break, 10:30 a.m. today. It's actually a very nice suite of tools. You describe your experiment in a Ruby-like language and script it, and and part of the script involves finding resources, pushing your software to those resources, and coordinating the control of the management of the experiment. There's a tool, SFace, actually it's being, there's a newer version called MySlice that we'll hopefully see a demo of perhaps, or is there a demo of MySlice? No, okay, not this time, all right, maybe next time. And then finally, the agenda, if you might have noticed the little green dots in some of the agenda items, green diamonds. These are sessions we recommend if you're a newcomer. So obviously the intro to GENI where you are, and then there's the OMF. I mentioned it's the framework for controlling experiments. That's at 10:30. And then there's a tutorial that starts at 1:30 and runs up to 5 with a break in between. And this will tell you how to program the GENI racks. And it will also tell you how to use the GIMI instrumentation and measurement system. So would strongly recommend that. And then likewise tomorrow afternoon, there's a tutorial on how to program the GENI racks. This is the second set of racks, and how to use the Gemini instrumentation measurement system. So in this spiral, in spiral 4, the Gemini instrumentation measurement system will work with the GENI racks, and the GIMI with the GENI racks. But this time next year, we should have both sets of instrumentation measurement systems working on both sets of racks. There's an experimenter roundtable, which is an opportunity for experimenters, people who currently use GENI, or people such as you who might have learned to use GENI in the previous 2 days, to give feedback to people building GENI. You could say, these things are really hard to use, or these things are great, we would like more of this or more of that. And so it's an opportunity for people building GENI to hear from you and provide you tools and services that might be helpful. There's also a WiMAX tutorial, which is also geared towards newcomers. And then there's the coding sprint. If, let's say you were planning on using GENI for your research, you would like somebody to help you, somebody from the GPO to help you get started. Or if you're stuck with debugging something, there'll be people from the GPO, Nikki, Sarah, Mark, who will be happy to get you started or help you work through any problems you run into. So again, that's, or if one of the tutorials, let's say you started on a hands-on exercise and you couldn't complete it, the coding sprint is a good place to go to actually complete the exercise. So I'd strongly recommend you try these hands-on tutorials, get a feel for what it is to use GENI to build, to develop experiments for GENI, and go to the coding sprint if you need any help. There's a demo session this evening where you will see people demonstrating experiments they've done on GENI, people demonstrating new tools or services that are available to experimenters, people demonstrating, showing off resources that are available to GENI experimenters. So that's, again, I highly recommend that. You should go, you'll get to meet people who are involved with GENI and see what's going on. There's usually good food and wine. And many of these tutorials require specialized software clients installed on your machine. To make it easy, what we have is a VirtualBox virtual machine with all the software you need installed. If you haven't already downloaded and installed the software in your machine, please see one of us at the GPO help desk. We have the software, and Nikki here has some. They're on USB drives, so you can just get the virtual machine image and put it on VirtualBox in your machine. So that should have the software you need to do the hands-on tutorial. Yes.
Can you tell them not to try to download it from the link you sent?
Okay, yes, and yes, it's a large file, over 3 gigabytes, so probably not something that the hotel network would stand up to. So at this point, if you need the virtual machine, please use one of the USB drives and don't try to download it.